Hello, I'm Satish Singhal. I'd like to talk to you in this video about pointers. Before I do that, however, I would like to talk to you about address of program variables. All program variables, constants, and even function names have address in their memory or in the RAM. These addresses can be printed out simply by using the address of or ampersand operator, which is this operator. In this video, I'll be using word variable for a while in generic sense. That means I'll use it for variables, constants, and function names. Okay? So I do not mean that I am only talking about those kind of program entities whose values can be changed. When I say word variable, I also mean to include, at least in this video, the constants and function names. Let's look at the example for a variable and its address. The code fragment below will print the address of variable num onto the console. So I'm declaring int num holding value of -10. If I do this, it'll print the address where this variable called num has been stored in the RAM, and it'll be displayed in hexadecimal numbers. Notice address value that will be displayed will not remain same for all program invocations. It will change each time the program is run. The operating system guarantees you only that certain part of RAM will be allocated for your program variables. It does not guarantee that it will allocate the same location in the RAM each time you run your program. So this address that we are printing here will change each time. Okay? Since every variable, constant, etc. will have an address, sometimes we make use of the address value of a variable. That's when pointers come into picture. And basically the special data type that can store the address of variables are called pointers. Okay? Now let's go to the next slide and look at that. Well, first let's look at the memory map of the data. I'm making this declaration here, int num equal to -10. Think of this cloud here as the cloud representing as RAM inside the computer. As soon as this declaration is made, following things happen. Inside the RAM, a box is created. It's given an address, it's given a name, and since the value stored there is -10, a value of -10 is stored inside. Okay? Now address value I've used here is a fictitious one. As I said, it depends on operating system what value is assigned. So the whole thing means I create a location in RAM which is called num. It has certain address. In this case I'm assuming it to be 1004, and it stores -10 inside that location. Let's look at the declaration of an integer pointer, int pointer. My code already had that. Now I declare int pointer like this. Int data type is star or asterisk, pointer variable name ptr, assignment operator, and a value of 0. Okay? You can do the assignment equal to 0 or not, doesn't matter. But if you do the assignment equal to 0, then pointer stores 0 inside. So in any case, when we make this declaration, this is what happens. Inside the RAM, a location is created. Its name is ptr. It stores 0, and it has its own address, which I called 1064. Again, that's a hypothetical value. Okay. This is called pointer initialized to 0. A pointer initialized to 0 does not point to anything. In other words, it does not yet have a pointee. Okay. But it can hold address of a pointer. It can hold address of an integer. Okay. Now we do the assignment where a pointer can hold address of a pointee. Okay. Assigning a pointee to a pointer is a separate step. We assign pointee to a pointer by setting the value to be stored inside the pointer equal to the address of the variable. So when I make this assignment, what I'm saying is that take my pointer ptr, inside it is store the address of num. Since address of num is 1004, the 1004 gets stored here. Okay. And as soon as that happens, it is customary for us to show this arrow as if this variable ptr, which is a pointer, is pointing to location in the RAM where num is stored. Okay. So as soon as I make this assignment, ptr stores the address 1004, which is the address of the num. Understand, inside RAM you don't actually have arrows. This is just for the convenience of visualization. But this is customary that we say that pointer is pointing to the num because it's storing the address 1004. Okay. The address of pointer itself is inconsequential at this point. So now let's actually go to our Visual Studio and then see that if address is stored inside the pointer is actually address of num, we should be able to print address of num two different ways and convince ourselves that pointer does store address of num. Okay, so here same thing, I store num equal to -10. I create a pointer ptr. I make it store address of num. Now I'm printing out address of num two different ways. Here, by putting the ampersand, num means print the address of num. And since ptr was assigned address of num, now I'm just printing address of num through the value that got stored in ptr. So let's just run this program. It's a little slow. And notice these two numbers, which are in hexadecimal values, are identical, 0012FF60, which means the two addresses printed, one through the ampersand operator, one through the value stored inside the pointer ptr, are identical. We can make it a little easier for you to read these numbers. We can cast them to integer type. That is done by using this piece of code here. So I can comment this out, but comment this in. Now if I cast this address to long type, it will give me the numbers that you can read on the decimal scale. Of course I have to compile it again, and it's going to be a little slow. And now of course you can read these numbers. The address printed through the ampersand operator applied to num is 1245024. Address printed through the value that got stored in ptr is 1245024. Okay, so pointer stores the address of the variable whose address is assigned to it. For example, this type of expression. Okay, back to our PowerPoint. Okay, so basically what that means is when we do something like this, we've taken the pointer PTR, assigned it a pointee. So PTR is the pointer, num is the pointee, pointer, pointee. Do not forget this relationship. Pointers store address of pointees. Without pointees, pointers are totally useless. Do not forget that either. They have absolutely no function to serve unless they store address of a pointee. I said that before. The dangling pointers. Maybe I'll talk about this very soon. Okay. So once attached to a pointee, we can have read access to the pointee through its pointer. So pointers are used to get read and write access to pointees indirectly. This is done by putting the asterisk in front of the pointer name. Okay. Here PTR got assigned to a pointee called num. If I write a program statement like this one, this is cout is outputting something. Here the name of the pointer, and I put asterisk in front of the name of the pointer. That will print to console a value -10. Okay, that's going to print -10 to the console, which means I'm getting the read access to the value -10 stored in num by putting the asterisk in front of the pointer PTR. Okay, this is called dereferencing a pointer. The syntax of putting an asterisk in front of pointer name is called dereferencing a pointer. It's also called indirection. Do not let this name dereferencing scare you. Okay? When we execute this statement, what happens? This is what happens. It is telling the program that follow the pointer to pointee whose address is stored here. So follow the pointer to 1004. Grab the value stored there, -10, and output the grabbed value to the console. Okay? This statement means follow the pointer PTR to the location whose address is stored inside the PTR. So I go here, grab the value stored there, which is -10, and since I have cout here, output that value -10 onto the console. Okay, this is called following the pointer to its pointee and grabbing that value. This is called dereferencing. So what happens is that when we do dereferencing, putting an asterisk in front of the pointer name, this whole thing becomes an alias for the pointee. Okay, pointee num has its own name, but now star PTR is another name for it. It's an alias for the pointee called num. Understand, dereferencing is not a double pointer. Okay? When we put asterisk in front of a pointer variable, the meaning is as follows. I'm repeating myself here. Follow the pointer to the address stored in the pointer or to the pointee. Grab the value of pointee. With that value, we do whatever program statement directs us to do. For example, in previous case, it directed us to output it to the console. So star PTR or asterisk PTR is dereferencing or follow the pointer. Dereferencing is not a double pointer. Okay. So in the previous slide, I showed you how this outputs the value to the console. Let's take a look at it in the Visual Studio. So I'm going to comment this out because I've already seen it. Let me actually print out the value of pointee num through the dereferenced value of pointer PTR. This should print 10 to the console. Compile. And actually minus 10. So my value was minus 10 and prints minus 10 as expected. Okay. That's how dereferencing works. We can also have write access to pointee through the pointer. After doing all this, I can have a statement like this. Asterisk PTR equal to 99. Meaning of that is that follow the pointer to its pointee, change the value stored there to 99. So this is the address of the pointee. Follow the pointer to pointee. The previous value there was 10. That gets thrown out. New value 99 is stored in the num. Okay. This provides the right access to the pointee through the pointer. As I said earlier, since asterisk PTR is the alias for num, I can use this assembly like the name num. Okay. So if I were to add a statement here, cout star PTR at this point, that should print 99. Let us do that in Visual Studio as well. And I can leave this because previous value it will show was minus 10. The new value is going to show is 99. Each time I have to compile and run. It's a little slow because I'm making this video. Here we go. So old value was minus 10. That was assigned here. But now I use the alias for the num, which is asterisk PTR. Put a new value there. So it follows the pointer to the location where num is stored, changes the value to 99, and now I print it after that and prints 99. Okay. So I can have the write access to the pointee through the pointer. So pointer allows read and write access to its pointee by using this alias, asterisk PTR. The syntax of read and write access through pointer is very important. Putting asterisk in front of the pointer makes it an alias for the name of its pointee. Program statements such as this gives read access to pointee. In this case, it will print pointee value to the console. Program statement like this one gives write access to the pointee, it will change the value stored in pointee to 99. Okay? So please understand the syntax of read and write access or syntax of dereferencing. This is also called indirection, by the way, which is a very cryptic term. But once you understand what it does, the name to it will not matter too much. There are other syntaxes available for creating a pointer variable, a pointer type. This is one syntax where star is attached to the data type. Here's another syntax where star or asterisk is not attached to either the variable name or the data type. The third syntax is this, where asterisk is attached to the variable name. Okay? It doesn't matter where you place the asterisk, it's a matter of style, but just understand what that means. Okay, there is a multiple pointer variable declaration as well. This statement here creates 5 pointer variables: ptr1, ptr2, ptr3, ptr4, and ptr5. None of them are initialized and none of them have pointees. We need to become familiar with few more terms. Uninitialized pointers are called dangling pointers. They're just dangling there. None of them have pointee either. Pointers without pointee are called orphan pointers. These are all orphans. They do not have a pointee. We look at yet one more declaration. You can mix pointer and non-pointer declaration in one line. I do not recommend doing that, but you will read the code written like this, which to some students is confusing, like this. Okay, some of you may get confused thinking that these are all pointers because I have in star here and these are double pointers. Actually not so. In this declaration, value and data, which is this one and this one here, these are int type, but num, ptr, and iptr, these are all pointer types. This asterisk actually applies to the num. Okay, so this is how the multiple declaration of pointer and non-pointer type work. Okay, this is also very important. Pointers can only store address of the type of pointee matching data type in their declaration. Let's look at that. Pointers that are declared as certain type are not free to store address of pointee of other types. If I declare int asterisk ptr, ptr can only store address of integer type. Okay, but if I do something like this, int asterisk ptr, then I have variable called GPA, which is double type, value 3.9, and then I say ptr equal to address of GPA. Wow, this is a compile error. This will not work. Let's take a look at it. GPA equal to 3.9. Let's try to compile it. Failed. It says assignment cannot convert from double to int. So basically it's telling you in very polite terms that ptr is only allowed to hold address of pointer type. It cannot hold address of a double type. Very simply that. So something like this is a compile error. Let's look at the pointer of other type. If I make declaration like this, char asterisk cptr, this is a pointer to a character type. If I have string asterisk sptr, this is a pointer to a string type. If I have a double asterisk dptr, this is a pointer to double type. If I say float asterisk fptr equal to 0, this is a pointer to float type. This one has been initialized to 0 or null. 0 in pointer technology is considered null. If I have a class struct or union called student asterisk is s2 ptr, this can store address of a student object, which could be class struct or union. All other than fptr are dangling pointers. All are orphan pointers. Pointers that do not point to a pointee are orphan pointers. Here's an important point also. Dereferencing an orphan pointer will crash your program. Okay? For pointers to do something useful, it must be attached to a pointee. As I said earlier, if a pointer is not attached to a pointee, it is totally useless. An orphan pointer should not be dereferenced. An attempt to dereference an orphan pointer will crash your program. And let's look at the examples of this kind of crash, this kind of disaster in Visual Studio. Okay, let's create an orphan pointer. I'm going to uncomment this thing here. Or actually I don't have to. I'm just going to create a pointer of double type dptr. Okay, so this is an orphan pointer. There is no pointee attached to it. I try to dereference it, try to get it to print its pointee, which doesn't exist, to the console. dptr. So basically I'm trying to repeat this step even though dptr is not attached to anything. Let's compile and run it. Okay, now here the compiler saved us. It doesn't actually okay, actually I forgot to put this star here. Let's do this. Sorry about that. Okay, let's compile again. This should compile. Okay. Now the compiler does give you a warning, but it does compile. Now let's run it and then see what happens. Wow. It comes up with this nasty message. Variable dptr being used without being initialized. What the program is telling you, or Visual Studio is telling you in very polite terms, is the dptr does not have a pointee. It's an orphan. If you try to dereference an orphan pointer, that's pretty much what happens, what you just saw. Your program will crash. Setting it equal to 0 where it stores null is not going to help too much. You might not get a highly nasty message, but program will still throw some sort of exception, some sort of error. Okay, so this time it still crashes the program, only the error message is different. Okay, so at the end I want to make this very, very, very strong recommendation or hint or an advice. Do not dereference an orphan pointer. An orphan pointer is a pointer which does not point to a pointee. You create a pointer, but never forget to assign it a pointee. Pointers without pointee are useless. There's nothing you can do with them. And attempt to dereference them like the way I've done here will always crash your program. Okay, thank you. In the next video, I would like to talk to you about how to allocate memory using the pointers.